My name is Sebastian Vievard. I am an astronomer working on exoplanet instrumentation at the Subaru Telescope in Hawaii. The first instrument is, with complicated word, a spectrointerferometer that is installed at the Subaru Telescope. What it does is that it creates images of stars and system of stars to try to detect companions around the stars, like exoplanets, which are planets outside of the solar system, or double stars. And we're basically trying to catalog them and to characterize them thanks to this instrument, meaning that we're trying to look at their colors, their composition. So in classic imaging, usually we just take a picture of the star, but because the star is so bright, we cannot see anything around. So any potential exoplanet, we cannot see them. So what they do in classic imaging is, one of the things they do is put a coronagraph in front of it, which is a little mask to cancel the light of the star and try to unveil the surroundings of the star. The issue here with this technique is that you cannot see behind this mask. And so what we're trying to do with what's called this interferometer is to image things that are basically behind this mask. So we don't need the mask, and we can look deeper and closer to the star than what the mask can do. So it's kind of complementary to the direct imaging technique. So what we observed for our first light was, at least at the Subaru Telescope, was first tested at the Lick Observatory and was very successful. So that's why it came then to the Subaru Telescope, which is a bigger telescope. So what we tested was to make sure that we can measure relative positioning between two stars that are very close to each other. So we did that on what's called the Hokulei system. And we did it during 2 days to make sure that we can follow the companion on its orbit around the central star. And the second thing that we did was to try to assess what the sensitivity of our instrument is, meaning how faint can we look at a companion next to a star and how close to the star can we go. And we found that we can basically go down to a quarter of what a normal imaging telescope could do. The reason why I chose to name the star by their Hawaiian name was to acknowledge the fact that the mountain on which we are most fortunate to observe, Mauna Kea, is first, before being an observatory, it is one of the most sacred places in Hawaiian culture. Just working here is a privilege, and I think it's important to acknowledge this. And I also think that it's very interesting to learn about what the stars that we're looking at meant in Hawaiian culture, who has very strong links with astronomy. So that's why I wanted to learn more about these stars and their Hawaiian names.